So, in the previous classes, we have learned how to expand a determinant, applications of determinant, and all the properties of determinant. And yesterday only, I think we have done 3 determinants which I asked you to remember. Yes or no? Yes or no? Hello, am I audible? Hello, am I audible?
Yes, sir.
So yesterday I also taught you 3 determinants to remember. Yes or no? Write down a question based on that. If A, B, and C are the sides of a triangle and determinant ABC, BCA, CAB. This value goes 0. Then identify the type of triangle. Yes, how do we do it? Any idea? Anybody? See, if you remember, I told you ABC, BCA, CAB. This goes 0. Abhishek, if I'm not wrong, have we done it yesterday? Expansion of this? Ramaksha, have we done it to yesterday? Hello?
Sir.
Yesterday we have done it or not?
Sir.
Anyways, well, its expansion I have told you, minus of A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA goes 0. Right? Now see, since ABC are the sides of the triangle, this A plus B plus C will not go 0. That means A square plus B square plus C square minus AB minus BC minus CA will be 0. Now multiply this entire equation by 2. You get 2A square plus 2B square plus 2C square minus 2AB minus 2BC minus 2CA equals to 0, correct? Now it can be written as A square plus B square minus 2AB plus B square plus C square minus 2BC plus C square plus A square minus 2CA. This is 0. Now tell me, what is this? Isn't it A minus B whole square plus B minus C whole square plus C minus A whole square 0. Now if this is 0, what does it mean? If this A minus B whole square plus B minus C whole square plus C minus A whole square is getting 0, what does it mean? This implies A equals to B equals to C, only then it can happen. If sum of 3 perfect squares is 0, that means each one of them should be 0 simultaneously. So A minus B will be 0, B minus C will be 0, and C minus A will also be 0. That means A equals to B equals to C. Correct or wrong?
Yes, sir.
Yes. So that means A equals to B equals to C. That means triangle is equilateral. Correct? Now, another property of determinant, which yesterday I forgot to mention, if any two rows or any two columns of a determinant are interchanged, if any two rows or any two columns of a determinant are interchanged, the value of the determinant changes in sign only. If any two rows or any two columns of a determinant are interchanged, the value of the determinant changes in sign only. Sign only means if it is positive, it will become negative. That means, say you have a determinant A, B, C, E, Q, R, X, Y, Z. Now you interchange its first and second row. So your first row becomes PQR, your second row becomes ABC, third row is as it is. So value of determinant will change in sign and it will become negative of this. Am I clear? So this
Yes,
is
sir.
how we deal with this property. All right. Now write down a question. Prove that determinant x, x square, yz, y, y square, zx, z, z square, xy, determinant is equals to 1 x square x cube, 1 y square y cube, 1 z square z cube, and that is further equals to x minus y minus z, z minus x, xy plus yz plus zx. Yes. How will you try it? First of all, how to convert from first determinant to second determinant? Yes, anybody, any particular strategy they want to share? See, yesterday property I told you, if you want to take something common from a determinant, you can take it common from any one of the rows or any one of the columns. Yes or no?
Yes, sir.
That means, let's do one thing. LHS I'm taking care of. Take XYZ common from this row. So what do you get? XYZ outside, determinant x, x square 1 by x, y, y square 1 by y, and z, z square 1 by z. Convinced? From the third row, third column, I extracted XYZ. Correct? Now do one thing. Multiply this x to the first row. Multiply this y to the second row and this z to the third row. If you do this, your first row becomes x square x cube 1. Y square y cube 1 and z square z cube. Am I correct?
Yes, sir.
Now, let us interchange these two rows. So first row will become 1, 1, 1. Second row will remain same and third row will become x square, y square, z square. After that, exchange second and third, second and third row. So with this procedure, your first row becomes 1, 1, 1. Second row will be x square, y square, z square. And third will be x cube, y cube, z cube. So this is how we complete the first part of the question. Now, then I told you, if we get 1, 1, 1 in any of the rows, our half work is done. Now use an operation. Write R2 as R2 minus R1 and R3 as R3 minus R1. So your R1 remains unchanged, 1x square x cube, R2 minus R1 0, y square minus x square, y cube minus x cube, 0, z square minus x square, z cube minus x cube, correct? Now, from this particular row, y minus x common, and from this particular row, z minus x common. So take y minus x common from second row and z minus x common from third row. So 1 x square x cube, 0, this will become y plus x, this will be y square plus x square plus yx. 0, z plus x, this will be z square plus x square plus zx. Now since you are done with this, simply expand it along the first column. Complete quickly. Now y minus x, z minus x inside the bracket, expansion along the first column, it will be y plus x, z square plus x square plus zx minus z plus x into x square plus y square plus xy. Now if you factorize it and simplify it, you finally get y minus x, z minus x, z minus y into xy plus yz plus zx. Take minus common from these two and your cyclic order will be maintained. So it is x minus y, y minus z, z minus x into xy plus yz plus zx. Understood? Am I clear? Now, let's do another question. So the question is, determinant b plus c, c, b, c, c plus a, b, a plus b. This is equals to 4 times a, b, c. Prove that. Okay, give it a try quickly. Quick, quick, quick. See, operations are all we require, because if you directly expand it, it will be very lengthy and tough to manage sometimes. So what do? I write first of all C1 as C1 minus C2 plus C3. So it will be 0. It will become minus 2a. It will also become minus 2a. C, B, C plus A, and A plus B. Am I correct? Have a look. Now, one more 0 if I get. So for that, I do R2 ko you can write R2 minus R3. So that the 2a minus 2a cancels. So it will be 0 C B, 0 C minus B, and minus 2a, and A plus B. Correct? So this is, now you can expand it along the first column, minus 2a times minus BC minus BC. So it is 4 times ABC. That's it. Is it okay? All right. Write down the next question. Determinant a square plus 1 AB AC, AB B square plus 1 BC, AC BC, and C square plus 1. This is equals to 1 plus A square plus B square plus C square. Chandan, can you please switch off your mic? Yes. Now how to do? Quickly. Yes, how to do? Now see. To prove is 1 plus A square plus B square plus C square. All right. But there are A, B, A, C, A, B, B, C, these kind of things. Let's do one thing. Take A common from first row. So if you take A common, you get A square plus 1 upon A. This is B, this is C. Correct? Then take B common from second row. So A here, B square plus 1 upon B, C. And then take C common from third row, A, B, C square plus 1 upon C. Am I correct up to this point? Now multiply A in the first column, multiply B in the second column, and multiply C in the third column. So if you do so, it will be A square plus 1, A square, A square. b square plus 1 b square, c square c square plus 1. Correct? Now if you realize the entire first row is the sum of 1 plus a square b square c square. Same is the second one and same is the third one. So now let us apply an operation. Write c1 as c1 plus c2 plus c3. So it will be determinant 1 plus a square plus b square plus c square, b square c square. 1 plus a square plus b square plus c square, b square plus 1 c square. 1 plus a square plus b square plus c square, b square c square plus 1. Now from the entire first row, 1 plus a square plus b square plus c square came common. So it is 1 b square c square, 1 plus b square c square, 1 b square and 1 plus c square. Correct? Now write R2 as R2 minus R1 and R3 as R3 minus R1 so that you can create two zeros. So 1 b square c square, 0 1 0 0 0 1. Now you expand it along the first column. What do you get? 1. So it will be 1 plus a square plus b square plus c square. That's it. Am I correct? Everybody understood? Now, write down another question. X, Y, Z are positive. X, Y, Z are positive and none of them is 1. None of them is 1. Find the value of determinant 1 log y base x log z base x log x base y 1 log z base y log x base z log y base z 1. Yes. Yes, any idea? Now see, this can be written as 1 log y upon log x log z upon log x log x upon log y 1 log z upon log y, log x upon log z, log y upon log z, 1. Let's do one thing. From the first row, take log x common. Even 1 by log x common. So what do you get? You get log x, log y, log z. From the second row, take 1 upon log y common. So you get log x, log y, log z. Now whatever the third row is, if in any determinant any two rows are identical, then the value of determinant goes 0. Understood? Is it okay? Now, try this question, second one, quickly. See, in this determinant delta k, two rows are there which are independent of n, k, sorry, which are independent of k. That means only one row matters to me. And yesterday we have done a property that if we want to add two determinants, if we want to add two determinants, that two rows or two columns should be same and they can be added or subtracted along the third row or third column. Like they are asking for sigma k from 1 to n delta k. That is delta 1 plus delta 2 plus delta 3 and so on delta n. Now see, in all of them, this row and this row, they are not dependent on k. They are independent of k. So, if it is so, I will have to add along the third row only, but means first column only. So, this will be what? In the summation, third row as it is, n square plus n square plus n plus 1, n square plus n and n square plus n plus 1. Then second row as it is, n square plus n plus 1 and n square. And first row will be 1 plus 1 plus 1 and so on 1 n times. Then it is 2k. So it is 2 into 1 plus 2 into 2 plus 2 into 3 and so on 2 into n. And then it is 2k minus 1, that is 1 plus 3 plus 5 plus 7 and so on 2n minus 1. Now tell me the sum for this particular row. 1, 1, 1 adding n times. Answer is n. Sum for this particular row, that is 1, 2 plus 4 plus 6 से लेके, that is n square plus n. And sum for third row, that is sum of first n odd natural numbers, that will be n square. Rest it is n square plus n plus 1, n square, n n square plus 1 and n square plus n plus 1. And this value is given to me as 56. Correct? Now, apply some operations to reduce the expression. I write, I write C2 to C2 minus C1 and C3 to C3 minus C1. So C1 is n square plus n square. This goes 0, this goes 1, this goes 0. Then 0, this is 0 and this is 1. Now this value is 56. So this value 56, if you expand it along this row, this goes, this goes. So what is the value of the determinant? N. So n equals to 56. Have I made some mistake? C3 minus C1 is not 1. C3 minus C1 is n plus 1. So that means factorization of the polynomial will be n into n plus 1 is 56. So value of n will be, now you can see 7 into 8. The value of n is 7. Correct? Now, try third question quickly. Quickly. Now it is a square bc ac plus c square. A square ab b square plus ac. And ab bc b square plus c b square c square. So how do we manage it? A square bc ac plus c square. See, you can take A common from first row, you can take B common from first column, B common from second column, and C common from third column. This is question number 3. See, the question is determinant A square BC A plus C into C. Then it is A into A plus B, B square AC. Then it is AB, B into B plus C, and it is C square. They are saying this is something like expand you have to do. Take A common from first column. So A came outside. It is A plus B, B. Correct? Take B common from second column, C. B, B plus C. Then A plus C, A, C. Correct? Now let's write C1 ko I'm writing row 1. Row 1 ko you can write row 1 minus row 2 plus row 3. So ABC outside. Now if I do row 1 minus row 2 plus row 3, so it becomes minus 2B. Then C minus B, this is also minus 2B, this will become 0. Then it is A plus B, B, A, B, B plus C, C. Correct? Now write C2 as C2 minus C1. So ABC is already there. No change in C1 minus 2B, A plus B, B. C2 minus C1, this is 0, this is minus A, this is C. And this is 0, A, C. Now, if you expand along the first row, you get ABC minus 2B times minus AC minus AC. So it is ABC into 4 times ABC. So it is 4 times A square, B square, C square. So if you go with the question, they are saying it is m times A ki power n, B ki power n, C ki power n. Means A is what? Means m came 4 and n came 2. So m plus n is 6 and m minus n is 2. Answer is AD. Understood? Am I clear? All right, everybody. Now, let's try 2 more questions. See, Lakshmi, there is no particular strategy that what to multiply where. This is just an observation. You will also get to know about it with respect to practice. The more you practice, the more exposure you will get that where we should multiply which number, which row to be subtracted from which row. So this is all about the exposure that we can get. All right. So there is no particular strategy. Like in this question particularly, what was visible to me? First of all, the only thing visible to me was take A common from here, B common from here, C common from here. So I took ABC common. Then what is my priority? To make 2 zeros in any row or any column. So from this, I subtracted, say, these 2 rows. So I'm getting 1 0. So once I applied that, automatically I get minus 2b here. So that means if I further subtract them, I'll get 2 zeros. So these things will come from practice. All right, they won't come in next day. Now try the question number 4. If the expansion of this determinant is x to the power n, then find the value of n. Yes, how to do? Anybody? Yes. See, the question is determinant x plus y, x, x. 5x plus 4y, 4x, 2x. 10x plus 8y, 8x, 3x. Okay. First of all, I have to simplify this. Rest all the things later on. So let's do one thing. Let us split it into two determinants, keeping the second and third column as it is. So in the first column, I'm keeping x, 5x, 10x. Second as it is x, 4x, 8x. Third as it is x, 2x, 3x. Now second determinant y, 4y, 8y. Then it is x, 4x, 8x, x, 2x, 3x. Chapter name is determinants. Now see here, if I take x common from this and y common from this, won't these two determinants will be identical? Tell me anybody. If I take y common from first column and x common from second column, won't the two determinants be two columns be identical?
Yes, sir.
And in a determinant, if two columns are identical, its value goes
0.
So this particular one goes 0. Now the first one I'm left with. Take x common from each row. Got it? This is 1, 1, 1, 5, 4, 2, 10, 8, 3. Now it's completely your call. How do you want to solve it? Keeping x as it is. First of all, what I do? Keep the first third row as it is. 1, 2, 3. Do column 2 co-write column 2 minus column 1. It will become 0, 2, 5. Then column 2 minus column 3. And column 1 ko also I'm writing column 1 minus column 3. So it will be 0, 3, 7. And now if you solve this determinant along this, value is 15 minus 14. So value is 1. So it will become x cube. All right. So value of n is 3. Understood, everyone? Am I clear?
Yes, sir.
Now go with this one. Quickly, this is very easy. First of all, split into two determinants. Then take something common from one of the determinants. Do it quickly. All right. Now, see, this question is determinant x, x square, 1 plus x cube, y, y square, 1 plus y cube, z, z square, 1 plus z cube is 0. All right. So first of all, what we do, I split it into two. keeping first and second column as it is, x, y, z, x square, y square, z square, 1, 1, 1, plus x, y, z, x square, y square, z square, and x cube, y cube, z cube. This value goes 0. Yes or no? Now, take x common from this row, y common from this row, and z common from this row. So it will become determinant. Okay, one more thing I would like to do here only. Replace these two rows and then replace these two rows. So 2 time changes means value of sign, matlab positive or negative won't affect. So it will be 1, 1, 1, x, y, z, x square, y square, z square. Plus, if you take x, y, z common, it will be 1, 1, 1, x, y, z, x square, y square, z square, and this value goes 0. Now from both of them, this entire, take this determinant common. 1 x, x square, 1 y, y square, and 1 z, z square. And in the bracket, it is 1 plus x, y, z. This value goes 0. Now, yesterday only, I told you the expansion of this determinant. Yes or no? Anybody who can tell me the expansion of this determinant? Yes, any one of you? Hanush? Anybody? Aksha?
X minus y into
Yes.
y minus z into
Z minus x equals to 0. Yes or no? Now this question itself saying that x is not equal to y, not equal to z. Yes or no? So if x, y, z all are distinct, that means this value can't be 0. That means 1 plus x, y, z equals to 0. That means x, y, z is equal to minus 1. Tell me, have you understood it? X, y, z equals to minus 1. Yes, anybody? Have a look again.
Unknown.
Now, just a recall of today's lecture. Mostly we have done examples today because maximum theory has already been covered yesterday. So the first question was that was dependent on yesterday's theory. That was if ABC are sides of a triangle and this is 0, then identify the type of triangle. Here, there were 3 things to learn. First of all, you need to remember this value or else you have to solve it in the exam. Then this cannot be 0 as a plus b plus c is 0. That means this value is 0. This value 0 means a minus b whole square plus b minus c whole square plus c minus a whole square is 0. And that means what? A equals to b equals to c. So triangle is equilateral. Then I told you a property that if we change 2 rows in a determinant, the value of the determinant changes in sign only. Means it was positive earlier, now it became negative if I change these two. If I apply this operation once again, like I exchange say this column and this column, then the sign will again reverse. So PAX as it will be RCZ, it will be QBY. So again one more minus came, so it became positive. Then first question that we have done, then I taught you how to take common from some column. This was the question. Then the simple question, b plus c, b, c, and so on. Okay, so I applied an operation, we got the desired result. Then this one, I took a common from first row, b common from second row, and c common from third row. And then I multiplied a in the first column, b in the second column, and c in the third column. This log question simple. Then we have done this question, which was dependent on the summation of determinants. Then the simple question again on the expansion. Then we have done these two questions. They were easy and not so difficult for you guys to understand. Anything? Anybody wants to ask something? Anybody? Yes, anybody who would like to ask something? Well, prepare more and practice more. We'll end this session here only. Thank you so much. Thank you, guys.